Okay, so hi, I'm Szymon Jóźwiak. I'm co-organizer of Hack of Tomorrow hackathon. And we need today for another webinar, another dose of knowledge. You can find our last webinar on AI agents topic made by Fetch AI on our channel. But today we will talk about something different. We will talk about AI powered energy communities with Grzegorz and Adam from Chain for Energy. And of course, Chain of Energy are one of our sponsors, and they also took an active part in the creation of the challenge, which you will hear about soon. So stay tuned. And of course, feel free to ask questions during the webinar. Greg and Adam will try to answer them at the end of the meeting. So as I said, feel free. That's not a problem. So let's get started. The stage is yours, Greg and Adam.
Okay, hey, hello guys. Pleasure to be here. Actually, it's a great honor to present our challenge at this pre-event webinar. So let me introduce ourselves. Sorry guys. Okay, let's do like that. Oh, it's here. Okay, sorry. So my name is Greg Sikora. I am co-founder and CIO of C4E project, and my background is technology. I studied at Warsaw University of Technology. I have plenty years of experience in telco, IT. I was working for T-Mobile in Deutsche Telekom, covering projects in Poland, in Germany, as well at group level, and I was building EMEA pre-sales structure for US-based startup in the communication platform as a service. Regarding blockchain, I am in this field since 2017, and when I understood what is distributed ledger, I am all in this field and trying to match traditional business, Web 2 and Web 3 use cases, and so the C4E is outcome of my experience as well. Adam, can you introduce yourself?
Yes, I can. Thank you, Greg. My name is Adam. I'm responsible for product development and marketing in C4E. I also have an experience quite big, actually, but since 2020, energy is my biggest hobby. So today, this is the time that I can share a little bit of energy with you guys. Thank you.
Yeah, today will be energetic. Okay, guys, let's continue. What is the goal of this webinar? So the main purpose, the umbrella of all activities related to Hack of Tomorrow is how to utilize AI technology in different use cases, and our use case is related to energy. And the most important is to understand how the energy works, what are the flows of the traditional energy sector, what are energy communities, and what is the power, why we are focused on this particular use case. And then we will try to explain how AI can help to manage the energy and what kind of use cases we can take into account. And of course, what is the role of C4E and what we are trying to do and how we see our value proposition related to energy, AI, IoT, and so on. But quickly about us, about project. C4E is the project which was born in our garage, let's say, the OVO, our mother company, is the company having great experience in telco and IoT use cases, and we figure out how we can utilize this experience in the energy sector. And we are trying to utilize technologies like IoT, AI, blockchain to fulfill the most effective way of how the energy can be traded in the peer-to-peer mode, and how the energy can be managed. And we have partnership with such players like Fetch AI. We are part of Fetch Foundation with Bosch, who is as well the co-founder of Fetch Foundation, with T-Mobile, Deutsche Telekom, and Granton, the IoT device manufacturer. So this is quickly about the project itself. If you want to know more about us, definitely go to our webpage, our social media, and you will know more about what we are doing. And right now, let me pass mic to Adam, and Adam will explain the energy itself, energy communities, and what we are trying to achieve in this field.
Thank you, Greg. There's only one question. Do you see my screen? I hope you do. It'll be there. Okay. Guys, traditional energy systems struggle with high costs and the need to be more eco-friendly. This is important. Energy communities help by letting local groups produce, share, and trade electricity, making, of course, power cheaper, greener, but AI makes this even better by helping balance energy use, manage supply and demand, and make smarter decisions in real time. Understanding them will be the key to building AI solutions during the hackathon. Let me just change the screen. Big corporations control the market, causing high prices, wasted energy, and little transparency. This leads to the three main problems: high cost, expensive infrastructure, low efficiency because of centralized supply, and privacy risk. People have little say in where the energy comes from. So how energy actually works? Most energy systems today rely on centralized production, where a few large power plants generate electricity for an entire region. Typical energy ecosystem: energy production. Energy is produced from fossil fuels or renewable sources. Once produced, electricity is transmitted through high voltage power lines and distributed to homes and businesses. Finally, energy is used in households, factories, or, for example, for air conditioning stuff. Types of energy we can recognize like conventional energy and renewable energy. So these are typical two sources. Both are important, but the shift to clean energy is changing how we produce and use power. So conventional energy includes coal and gas, and renewable energy, which includes solar, wind, hydro, biomass. Energy is changing. So this is the best part in this one. The old centralized model is giving way to local control. Communities are shifting from relying on big utility companies to producing, sharing, and manage their own energy. So this shift is happening as more energy comes from solar and wind, reducing dependence on fossil fuels. Smart technology, like we do, like blockchain, like AI, like IoT, is making energy management more efficient. So at the same time, decentralization is giving local communities more space to take control of their energy, which is very important to this subject, energy communities. Energy communities give people control of their energy. Instead of relying on big energy companies, local groups, individuals, and businesses produce, share, and manage their own electricity. And by working together, they use more renewable sources like solar, wind, and these kind of sources. But what's important the most, they can save up to 30% of energy bills. And of course, they increase their energy independence. On the individual level, we have prosumers. So we are talking about people who generate and use their own energy, like with solar panels on the roof. But when prosumers work together, they form energy communities, groups that, as I said, produce, share, and trade energy in a local way. So by collaborating, they make energy much cheaper. That's why we are talking about energy communities today. And energy communities that people decide where their electricity comes from, how it's shared, and what it costs. They set their own rules, choose prices for local energy, and decide when to store power and send it to the grid. So this is important if we are talking about hackathon, you will see later on. Even without AI, they save up to 30% of electricity bills by buying energy together and selling extra power. But with AI, smarter energy flow, better use of storage means bigger savings. How much more could they save by predicting demand, tracking prices, and adjusting to the weather? That's the question. Maybe one of you will know the answer at the end of the hackathon. But to understand it well, there is the question, where do energy prices came from? And energy prices are constantly changing, influenced by multiple factors. The biggest driver is, of course, supply and demand. When demand is high, like in the evenings, when people return home, prices go up. When there is an energy surplus, prices drop. In Poland, electricity prices are set on the day-ahead market, RDN. This market allows energy producers and buyers to trade electricity 1 day in advance, ensuring prices reflect real market conditions. And why this RDN is important? It provides a transparent reflection of electricity cost. By setting prices hour by hour, it helps businesses and energy communities plan energy usage, manage cost efficiently. So on the right, you can see real market data showing how electricity prices change through the day, and prices peak during high demand hours and drop when demand is lower. Understanding these patterns is a key for optimizing energy cost, which is exactly what AI-powered solution can help with. How they work, actually. Members generate energy with solar panels and wind turbines. It's shared within the community with surplus energy stored or sent to the grid. C4E manages hourly billing and trading, ensuring fair pricing, and the result, lower cost and greater energy independence. C4E gives energy communities the tools to manage their electricity, the way they want. And by using real-time data from energy smart meters directly from solar panels and businesses as a consumers, along with market prices from RDN, communities can make smarter decisions. When energy is cheap, it should be stored in energy storage. When it's expensive, it makes sense to send it back to the grid, not buying from the grid. So this is just a little bit about energy, but I hope this is important. I hope you now see why AI is key to the process. It automates decisions, ensuring energy is used in the most efficient and cost-effective way. So in the end of the day, the goal for you, for electric communities also, is lower energy cost and maximize efficiency. And during this hackathon, you will be tackling real challenges and finding smart ways to manage energy. Our score for saving is 30%, and I hope, fingers crossed, that your saving will be much, much bigger. Thank you, Greg.
Okay, thank you, Adam. And right now, let me continue. So guys, right now, I hope so you better understand what we are doing, what is the role of energy communities. And right now, let me tackle a bit the AI topic, which is related to what we are doing. So let me explain a few basic concepts. If you are familiar with that, sorry about that, but I have to explain that because sometimes it's not clear. So usually when people are talking about AI agents, they means actually AI workflow. Usually like using some LLM like ChatGPT, you are entering input, using retrieval, the data which is available to large language model, tools like API calls, additional information which can be utilized during processing of the requests, memory, short-term, long-term to pass the information between queries. And then you have output. And this is actually not AI agent. This is the workflow. It can be straightforward. It can be more complicated. You can combine 2 or 3 LLMs to achieve your goal. Usually it is used in call center or CRM kind of tools where you have interaction with leads customers. But actually the agent, when we are talking about LLM, is the guy who is sitting here in front and interacting with human, and then he decides to do the action on environment and get the feedback from environment, which influence the next stage. And so you can imagine that this is the difference between previous and the current is that the action to execute specific action on behalf of human or other agent. And if we go further, then we can say, okay, if we have more than one agent who has access to context, to different models, it can be one or many models, additional tools and memory, short, long-term memory, then you need orchestration to orchestrate those agents to execute logic which you are expecting. And there is human interaction, which is not directly connected with, but can be as well, which you can treat as a kind of philharmonic kind of stuff, that there is orchestrator who is ruling agents. And then we are talking about multi-agent system where you have individual agents responsible for specific tasks, and those agents are either autonomous programs, and this is actually what we are doing, or robots, even robots, and then based on the environment, the state of the system, they are executing specific actions, and actions can be executed in collaborative mode and can be coordinated. And the most important is that there is this orchestrator who cares about the agentic system, how those agents are working together. And this is actually what we are trying to achieve is when we connect energy with AI, we have higher efficiency. We want to have decentralization and autonomy. This is very important from the future bulletproof energy system. Increased reliability and resilience. Of course, lower cost. It has to be cost efficient and innovative, and we want to achieve innovative business model. And then what Adam shown before, when we have this concept of energy communities and we add agents who are responsible for specific tasks, like imagine that this guy is responsible for management of storage, this guy is responsible for wind turbine, like tracking energy production, but as well he can decide, okay, right now we have too much energy and energy can be negative, so you are paying if you are sending energy to the grid. It can happen. So this agent can decide, okay, I don't want to produce energy right now. It's better to stop turbine. And other guys like agents responsible for AVAX, like air conditioning, heating, EV charging, the use case which we are as well focusing on. And then those guys are sending state the information about energy data, the flows, the environment, like energy price, weather prediction, and so on. This information is stored in the database, blockchain. And then you have energy management system, and you have this orchestrator, this guy who see everything, and he is executing actions, sending directly to agents. And those guys, they can accept this action, but of course they can say, okay, maybe I don't want to execute that, or maybe I will adapt this action and will do that in a bit different way. And then they are executing actions, and they are sending the next state to the system. And then you have this step-by-step incremental approach. And the most important to agents is to have the highest reward. And you can define this reward in different way. Those guys are working like humans. They are not working because somebody told them. They are working to have the highest reward. And in our approach, the reward is to maximize energy savings in the energy community. And this is what we are focused on. And we want to have we want to apply agents to achieve the highest energy savings, and this is what we are focused on. And we are inviting you to go with us and help us to design the system in a way that we have this goal achieved in the best way. We reframe that a bit to make it accessible and more clear, that you can understand what's going on. And right now I'm going to show you the tool which you can use as a basis for your task, and I'm gonna to explain what we are expecting from you to do in these tasks. And right now, let me change my screen. Give me a second. If there are some questions, just let me know. Okay, so we prepared simulator, which is called Fetch AI Agent Simulator. The name is on purpose because we want to that you will implement agent-based modeling techniques using Fetch AI agents. This tool doesn't have any Fetch AI agent implementation. This is static model showing what is the basis, how the baseline looks like, and then you will be responsible to improve that, to have higher efficiency. And how does it works? So before hackathon, you will be able to fetch, check out this project. Here is the information how to run it, what you can do. It is written in Python. And then you can run the simulation. And the simulation use some data. We have the information about storage. The storage is a very important component of energy storage, the very important component of energy community, because this storage can be loaded, unloaded. And it allows to manage energy in the community. If you have energy production and you don't have energy consumption, the best approach is to store energy in the energy storage and use it when there is high energy price. And this is actually the most common use case from the energy storage perspective. The other use case is if you have weather prediction and you see that there will be storm and so on, then you can predictively load energy storage and you use it during a storm period. Then you have the information about production and energy production consumption. I'm gonna to explain that a bit later. The information where logs are logged and the grid cost. What is the cost of selling energy to the grid and buying energy from the grid? And then let me go one by one through this through data. So let's start from the grid cost. So this is the, let's say, one example day of energy cost for purchasing and selling from this day-ahead market, where you have hour by hour energy, and this cost is per kilowatt hour, and you have the cost of purchasing of energy and the cost of selling of energy. And you see that we assumed in the simulation that purchasing is more expensive versus selling. So agents, they have to care about this information. What is the cost of purchase and sell of energy from the grid? Then we have storage, and you can program your storage structure. So if you want to have bigger storages, energy storages, you can increase this number. This is kilowatt hours, so you can design how much energy you want to store in the energy storage, and you can as well add new energy storages. You can use hash to comment and uncomment them. So let's say we have two energy storages. The first one is 40, the second one is 60. For now, it's enough, the information. And then you have different profiles of point of delivery. Point of delivery is individual entity like home estate, home factory, PV installation, wind turbine, and so on. So each PPE has own production and consumption. And if you go into it, you see that this is like example 2 days from June 2023. We collected this data from example PPE. And you have production, this blue, and consumption, this yellow. And you have hour by hour. In this case, we have 2 days in this file. And you have the second PPE, the third, another. So you have 1, 2, 3, 6 PPEs. So those PPEs are creating your energy community. And right now, what we are going to do, we are going to run this simulation just like that using Python. The name of this tool, what storages file, PV profiles. I want to use these 2 days. It will be easier to explain where logs will go and what is the cost of energy from grid. And we are running simulation. That's it. It was quick. And we have here results. We have actually 3 files. We have PNG. This is the I'm gonna to explain that in a bit. The chart of with different data. We have the detailed data like what is the total consumption, total production, token balance, and so on. And we have logs showing what was the execution during each step. You have the step, the date, and time, and what was the total consumption, production, energy surplus, and so on and so on. I'm going to explain that later on. And right now, let me show this draw, and it will be the easiest to explain what's going on here. And we have 2 days. We have total production and total consumption of this energy community. So you have the profile of consumption and production. Of course, production during the night is 0, during the day is increasing and then going to 0, and so on and so on. Then here we have energy prices. Energy prices when we want to buy from grid, this orange. The green one is when we want to sell energy to the grid. And here we have peer-to-peer price. And in this particular simulation, it is fixed to 0.5. 0.5 token per kilowatt hour. So I'm gonna to explain later on what is the role of token, but you can treat that as a currency in this simulation. So everything is calculated in tokens. They are called community tokens. And then we have energy storages. And if you remember, we have 2 energy storages. And we have storage number 1, this blue one. And you see it goes to the max. Let me check. And it goes to the max, and then is discharged. Discharge, I suppose I forgot to save it. And then you have another storage, this one, which is charged to half, and then once this one is full, then we are charging in further. Here we have energy deficit. It means that how much energy we are missing in the energy community. So it means that at the beginning, where we didn't have energy production, you see, and we had energy consumption, so we were missing more or less 5K of energy, which we had to wait until we have day, and then we are fine. We have enough energy in our energy storages. And from that perspective, we are fine. Then we have energy surplus over time. It shows how much energy we sold to grid, and this is very important as well to manage that we can earn as well on energy selling. Then we have token balance, and this token, as I said, represents the energy sorry, this is the currency in this simulation. And we have rule, and if you go to this file, we have rule that whenever energy is produced in the community and used in community, we are minting 0.1 of token per kilowatt hour. When we are buying energy from the grid, we are burning 0.1 token per kilowatt hour. So as you see, the most from this perspective, when we are using energy from renewable energy sources in the community, you have more tokens. When you are using energy from grid, you are losing tokens. So, and if you go back to this diagram, you see that in this particular case, let me make it larger. I hope so that you see that. At the beginning, we have around 100 C4E tokens, community tokens. Then it goes down because we are using energy from the grid, and then it goes up because we are using energy from sun, goes down because still we are using energy from the grid, and goes up because we are using energy from the sun. So this is how it looks like, and right now I'm gonna to change a bit this simulation to show you how it changed the behavior. As I said, here we have log showing step by step what happened, and you can see the consequence of manipulation of this energy community. And right now, if I remove those two storages and right now change, for instance, to 20 kilowatt hour of energy, and if I run this simulation, so you see that its behavior is different. So what changed? The storage level. So my energy storage wasn't able to go to the max. Max is 20 almost. And here it was discharged to 0. And here we see that we have energy deficit, which shows that our energy community isn't balanced in a proper way. Definitely, we need bigger energy storage. And then if we see that the token balance, it's lower versus previous one. The previous one, we had 150. Here we have 100, almost 40. At the end, we have 130 something. And right now I can manipulate those data. I can add PPEs. I can remove PPEs, or can do the simulation for whole month. Maybe let me show how it looks like for whole month. And here I am running more advanced simulation. And if you see, here we have energy consumption. Production is really huge. So this is some example. We're gonna to change it during before the challenge. And here you see that you are collecting tokens. But if we change the profile of this energy community and we add more consumers, let me shift this here, and this, then it will change dramatically. I hope so. So first of all, what we see that we have higher consumption. Still, it's not so high, and we have less tokens. We have 450. Previously, we had 800. So the energy communities topic can be really complicated, but we want to simplify that. And the main challenge would be to have as much as possible tokens using the same data, the same profile, the same storages. And your role will be to adapt this code to utilize AI agents to take the decision how to charge, discharge energy storage, when to buy, sell energy from the grid, depend on the weather prediction, and so on. So this is more or less the challenge which you will have, and we will share more data just before challenge and what are rules for evaluation. So this is more or less what I wanted to share with you guys. I hope so it was productive. And right now maybe you have some questions, so still I'm here.
Yeah, of course. If you have any questions, feel free to ask. But for your information, this live will be also shared in public soon. So after this this live stream. So also if you will have questions after the live, don't worry. You still have a comments section for you. So yeah. Thank you very much, Greg, and thank you very much, Adam, for a really good webinar. And thank you also to all participations. And yeah, I think this webinar increased a bit our energy awareness and get you some informations about the challenge. Of course, whole information will be posted soon. And of course, the next webinar will be held in 2 days on Thursday at 5 p.m. also. So stay tuned. And again, thanks to Greg and Adam for this webinar and for introducing us to the topic of AI-powered energy communities. And also big thanks to Chain4Energy company that are our sponsor and partner of the hackathon. So thank you very much, guys, and see you soon.
Thank you, Szymon. It was a pleasure for me. Thank you. Bye.
Thank you very much. Bye.